Something is moving past our sun right now, and it shouldn't exist. At least not the way it does. Astronomers have been watching a strange object racing through our solar system faster than anything we've ever seen before. It's called 3I/Atlas, and it's not from here. In fact, it's only the third confirmed interstellar object in human history, a visitor from deep space that came hurtling toward our sun, defying every model and prediction we've had about how comets behave. The last time something like this happened with Oumuamua in 2017, it triggered years of debate theories of alien technology and questions that still haven't been answered. Now, Atlas is stirring that same energy all over again. But this time, the data is even stranger. On October the 29th, 2025 3I/Atlas reached its perihelion, its closest point to the Sun, just 4 astronomical units away inside the orbit of Mars. That's close enough for the Sun's heat to strip its surface bare, releasing vast clouds of gas and dust into space. Yet as this happens, we can't see it. The Sun's glare completely blocks our view. For now, the most mysterious interstellar object ever recorded is hidden behind the one star that defines our existence. When it emerges again in December, astronomers hope to see what the Sun did to it and whether it's still intact. But the story doesn't start there. It begins in July 2025, when the Atlas Telescope Network, a series of survey observatories across Hawaii, Chile, and South Africa, caught something unusual, a moving speck that wasn't where it should be. At first, it looked like a routine asteroid. Then, as its motion was analyzed, the realization hit this object was moving far too fast to belong to our solar system. Earth moves around the Sun at 30 kilometers per second. Mercury, the fastest planet, races at 48. But this thing was clocked at nearly 58 kilometers per second, and it was still far from the Sun, drifting near the orbit of Jupiter. That kind of speed means only one thing: it wasn't bound by the Sun's gravity. It wasn't falling in, it was passing through. 3I/Atlas was traveling on what's called a hyperbolic trajectory, the unmistakable signature of an interstellar traveler entering and leaving our solar system forever. The first one, Oumuamua, was cigar-shaped and eerily silent. The second two, I/Borisov, looked like a normal comet from another star. But this third one, Atlas, was different from both. Bigger, faster, and aligned almost perfectly with the flat plane of the solar system, as if it had chosen its path with precision. Only 3 degrees off the ecliptic, it skimmed through the planetary disk like a cosmic torpedo. That alignment alone is so improbable that it has baffled orbital physicists. Out of infinite possible directions in 3-dimensional space, how did an object from the galactic thick disk, possibly 7 billion years old, strike the solar system in such a perfect side-on trajectory? Coincidence? Maybe. Or maybe it tells us something deeper about how interstellar debris travels across the galaxy. For now, all we know is that it came from the direction of the Milky Way's core, the crowded heart of our galaxy, and that its path has brought it closer to our planets than any other visitor from the stars. As it races past the Sun, 3I/Atlas is shedding its frozen skin, releasing gases and metals that could reveal what kind of world it was born from and what kind of chaos it survived to get here. But the clues it's left behind are already rewriting what we thought we knew about comets and about our own solar system's place in the galaxy. Something about Atlas doesn't add up, and the deeper scientists look, the stranger it gets. When astronomers first analyzed the data from Atlas, what they saw didn't fit the normal playbook for a comet. The first red flag came from NASA's Transiting Exoplanet Survey satellite TESS, which had captured faint images of the object weeks before its official discovery. Between early May and June 2025, Atlas moved about 1 astronomical unit closer to the Sun, and in that time its brightness didn't just increase as expected, it exploded, rising nearly 5 times more than the models predicted. That's the kind of surge you'd expect from a body that's releasing far more gas and dust than usual. It told researchers this wasn't an asteroid at all, but a highly active comet, already venting material while still beyond the orbit of Jupiter, an impossible distance for normal ice to sublimate. The only logical explanation, its surface wasn't dominated by water ice like comets in our system, but by frozen carbon dioxide, dry ice, which evaporates at far colder temperatures. That discovery turned 3I/Atlas into a chemical outlier, a clue that it might have formed in a star system very different from ours. The more scientists looked, the more alien it seemed. Its coma, the glowing halo of gas surrounding it, showed a CO2 to water ratio of roughly 8:1, the reverse of what we find in homegrown comets. Then came something even harder to explain: its polarization signal, the way sunlight scatters off the dust around it. Every known comet and interstellar body, including Borisov, showed positive polarization light bouncing at right angles. Atlas, however, registered extreme negative polarization, meaning the light reflected almost straight back toward the sun. That has never been seen before in any object, natural or otherwise. To some researchers, it suggested exotic grain structures or minerals formed under ancient stable conditions. To others, it hinted at compositions we haven't yet encountered. But if the light was strange, the metals were stranger. When telescopes picked up spectral lines of nickel venting from Atlas's coma, scientists expected to see iron alongside it. The two elements are almost inseparable in cosmic chemistry, born together in the hearts of dying stars. Yet, at first, there was no iron at all. Nickel without iron defied the standard model of stellar debris. Some speculated that nickel could be dragged out by violent CO2 eruptions, while heavier iron stayed trapped below the surface. Others wondered whether Atlas's parent system had undergone an unusual kind of stellar evolution, creating material combinations we don't see here. Later observations in September did detect iron balancing the ratio and calming the mystery slightly, but the early data remained unexplainable. Even the way Atlas grew its tail seemed to ignore the rules. Typical comets develop tails that stretch away from the sun, sculpted by solar wind. But when Atlas first began venting gas in mid-2025, its tail pointed the wrong way toward the sun. That so-called anti-tail suggested the solar wind wasn't yet strong enough at its distance to overpower the momentum of its own outgassing. For weeks, astronomers watched a fan of dust accumulate on the sunward side before it finally flipped and flowed outward like a normal comet. Each anomaly deepened the sense that Atlas was more than just another icy traveler. It was a probe into how alien chemistry behaves when it meets the sun's heat for the first time in billions of years. As the object continued its plunge toward the inner solar system, the story of 3I/Atlas turned from observation to confrontation, a clash of interpretation between those who saw it as a natural relic of cosmic history and those who suspected something far stranger. In early October 2025, Atlas swept past Mars at just 0.19 astronomical units, the closest it would come to any planet. For planetary scientists, this was a once-in-a-lifetime opportunity. Mars isn't just another planet. It's a robotic outpost bristling with cameras. The Perseverance rover, the ExoMars orbiter, even the century-old veteran Mars Reconnaissance Orbiter were all in position to catch a glimpse. And they did. The Perseverance rover recorded a faint, streak-like smudge in the Martian night sky. After a 30-second exposure, nothing detailed but confirmation that this interstellar visitor was visible from another world. The ExoMars orbiter produced sharper data revealing a condensed coma and a faint fan-shaped tail. The clearest image, however, should have come from NASA's HiRISE telescope aboard the MRO, the most powerful camera orbiting Mars. But just as Atlas made its closest pass, the U.S. government shut down. With NASA staff furloughed image processing, and release came to a halt. For weeks, the public waited, conspiracy theories filled the gap, and the phrase, NASA data delay, started trending among space enthusiasts who believed the agency was hiding something. Officially, nothing unusual was being withheld. Unofficially, it fed into a growing narrative that maybe, just maybe, Atlas wasn't what we thought it was. After all, this object wasn't behaving like any comet known to science. Its brightness spiked erratically, its tail changed direction, and its chemistry looked engineered. Carbon dioxide propulsion, nickel vapor, trails a reflective pattern that baffled polarization models. Theories began to multiply. Was this a fragment of a destroyed planet from another system? A frozen core of an ancient exoplanet's moon? Or, as a few bold voices suggested, a relic of alien technology? Perhaps not a ship, but debris from something once artificial. Harvard astronomer Avi Loeb, already famous for proposing an artificial explanation for Oumuamua, resurfaced in interviews, pointing out the similarities in anomalous acceleration and composition. Others fired back, saying the evidence was perfectly consistent with natural physics. The object's CO2-rich surface explained both its early activity and light behavior. Its alignment with the solar plane, while statistically unlikely, could simply be coincidence. Yet the timing of events made everything look suspect. First, the delayed release of Mars imagery. Then the fact that we couldn't observe its perihelion because of the sun's glare. And finally, whispers that the Juno probe orbiting Jupiter was preparing a priority observation window for March 2026, just before Atlas slingshots out of the solar system forever. Every piece of this puzzle seemed to hover on the edge of revelation. In scientific journals, researchers cautiously described unprecedented polarization characteristics. In online forums, people translated that as something not natural. The truth, as always, seemed buried in the middle, tangled between physics perception and our own instinct to find patterns in the unknown. Atlas was neither silent nor predictable. It was performing a kind of cosmic theater, every observation teasing another question. And with the sun still hiding it from view, the suspense grew unbearable. When 3I/Atlas re-emerges from behind the sun in early December 2025, telescopes across Earth will turn toward it in unison. The goal is simple: to see what the sun's heat has done. Will the object still be intact, or will it have fractured under the stress of its first close encounter in billions of years? Whatever happens, the next phase of its journey will unfold fast. By mid-December, Atlas will be moving away from the sun, still trailing gases and dust, but cooling rapidly. On December 19th, it will make its closest approach to Earth, about 1.8 AU, before fading into the deep dark once again. Then, in March 2026, it will pass near Jupiter, just 0.36 AU away, offering the Juno spacecraft a final chance to capture images before it disappears forever into interstellar space. For astronomers, this is more than a fleeting visitor. It's a data point in a growing pattern. 3 interstellar objects in less than a decade suggest that our galaxy may be filled with wandering remnants of ancient worlds, each carrying chemical fingerprints from systems long dead. For the rest of us, Atlas forces a different kind of reflection. What does it mean that something older than Earth itself, formed in a distant region of the Milky Way, can pass through our solar system, leaving nothing behind but questions? Is this just cosmic coincidence, or evidence that the universe is more connected, more alive than we ever imagined? As Atlas fades into the void, we're left staring into the same night sky it came from, wondering how many more visitors like this are already on their way.